Hello, I'm Gautam Thakur. I'm a group leader for location intelligence at Oak Ridge National Laboratory. In today's talk, I would be talking about accelerated assessment of critical infrastructure in natural and human-made disasters. This is a joint work with a lot of researchers from my division, Geospatial Sciences and Human Security at Oak Ridge National Laboratory. So, when we think about a disaster, the first thing that comes to mind are people and critical infrastructure. And critical infrastructure that includes like bridges, like hospitals, museums, schools, etc. and etc. And the challenge here is to make biggest impact. It's important for the first responders and for the volunteers to act within 0 to 48 hours of this disaster that's being unfolded. But the challenge here is not about enacting in 48 hours. The challenge is how to effectively make that enactment. And for that purpose, it's very important that pre-disaster and the ongoing information has to be conflated together in a way that can be made available to the first responders in a timely manner for an effective post-disaster recovery. So how we could achieve that? What are the different sources that we can combine and how to make that available accurately and efficiently and in a precise manner to our first responders. So this research is all about that. In the current scenario, there are two different dimensions to how certain systems react to post-disaster or how they approach post-disaster recovery. The first is overhead satellite imagery, where we try to attempt to get a lot of information through different kinds of remote sensing data. It could be SOAR, could be aerial, could be satellite. And then we try to do change detection, or we try to extract certain features, or try to characterize the damages that has happened. On the other side of the spectrum are the ground level information that we can get through social media, through GPS footprint, and other forms of IoTs and other forms of signals that we can get that characterizes what's happening from the ground level. In this work, we try to kind of hybridize these both together. So we try to combine the satellite level imagery, but also get a relevant ground level information and try to fuse them together for a more meaningful information. And there are certain things that are important when it comes to creating these data sets. The first is assessment level. How fine-grained assessment of damages could be achieved? What is the confidence that certain buildings or certain schools are damaged, for example? And can we do that at a finer spatial and temporal scale? So this work is kind of creating this framework, a 6-step process that could be achieved within 0 to 24 hours or 0 to 48 hours of a disasters, and should be able to spit out relevant data sets to first responders and to other agencies involved in the recovery mechanism. Of course, the first thing starts with the data collection framework and a data intensive architecture that we have built and proposed in this work. It was also published in 2015 6 Spatial. The second step is towards collecting the data, different kinds of data that we can think of, and how to effectively collect the data given if the disaster area is very large, say 100 square kilometers. So how we could achieve an effective data collection for that matter. The third step is foundation data enrichment. Once we collect the data through different sources, how to effectively clean and use that data. So there is a need to perform an automated data assessment for everything that we collect. Maybe create a more coherent, uniform data sources that could allow us to easily conflict different kinds of data. The fourth step is using satellite imagery and other forms of airborne imagery. Try to perform a first stab at what the level of damage that we're looking for. Maybe try to identify the area, for example, that has been damaged because of, say, hurricanes. And the fifth step would be then to go into add individual building or blocks, and then try to find the fine-grained damage assessment that could be done using the ground level data. Now, even so far, what we have done is fully automated. Yes, we can collect the data from different sources. We can use artificial intelligence and deep learning neural network models to extract features or perform change detection and other forms of analysis as well. Still, because of the messiness of the data, it is very important to have a human in loop or a human machine teaming as part of the entire system. So as the final check can be made by geospatial analysts or people who are aware and understand the location, as well as aware and understand the situation in which they are operating. So the final and the sixth step is where we can perform a lot of quality assurance and assessment of this data. Finally, this is the architecture that we proposed at some point of time in 2015 on Planet Sense. This architecture basically combines data collection as well as processing of information in real time, and then provide the assessment to some of our sponsors as well as nonprofit organization on the right side. The bottom is where we perform a lot of QA/QC for assessment of the data as well as the assessment of all the information that we extract from different sources. Finally, when we start looking at so the second step towards M2 is towards collecting the data. Now, if we have to collect the data, we understand that where there are people, there is the data. So what we try to assess is to use population data as a way to understand where people are. So if you see an example here, we use the Landscan Global 2016 population here in the red color, and then created an assessment of function of how small a grid could be based on how much the population is. So this can kind of captures this in a much clearer way. There's a large grid with say 1 degree by 1 degree. If there are more than 5,000 people, we split that grid into 4. If each grid has more than 5,000 people, we split that grid further. So now the idea then is to use each grid and try to find information, maybe through social media, maybe through satellite data, or through other forms of geospatial information that we can collect. Also, we can now distribute this to several hundred machines that are responsible for capturing and managing just one grid. That way we can parallelize our effort. And this is kind of something that we ideally wanted to perform every time when we do this kind of a work. The next step after this is then we can, how much is the information that we can save using this kind of an approach? So as we have seen here that if we look for like 1 kilometer grid for say Egypt, we have over 1.25 million for different kinds of grid, but using our approach, we only have 41,000 grids that we can find for this kind of work. So once we collect the data, as we have seen here, the next step now is to basically see how we have used our information in different case studies. Now, again, each disaster is different, each disaster preparation is different, and each disaster unfolding is different. So we try to kind of then see what is the best approach to perform and assess and perform the data collection for this. So for the Bahamas during Hurricane Dorian, we did change detection to first get the pre-event and the post-event imagery as shown in these pictures. The next step would be then to identify the impacted buildings and how those identified buildings have changed this before and after the disasters. But since even with the satellite imagery, we can only identify and assess the blocks or the features that have been impacted. We don't necessarily tell whether that building is a school or that building is a museum or an amusement park. So we do a lot of points of interest data collection. We do a lot of ground photo data collection for that matter. And then we try to perform what kind of an assessment we could do. So we try to rely on a lot of volunteers as well as social media and crowdsource information to collect different kinds of data. We collect several thousands to 1 million pictures for a disaster. And so there's a need for us to automate the data extraction or the feature extraction for this. So we basically have put together a framework based on low shot learning that identify like 8 different types of categories that are very relevant to the disaster event related information classes. And that includes like rescues, that includes military preparation, or that includes ongoing disasters or damage, as well as certain victims, for example. And then we try to identify which areas have a higher threshold, which information is more relevant for which kind of recovery efforts that has to be made in this case. So this is kind of a level of damage and the assessment that has been performed recently for the Hurricane Dorian that happened in Bahamas a couple of years back. And we also kind of use human-in-machine and human-machine teaming to identify some level of confidence in these results. Similar studies we did for the port of Beirut, where we try to identify what the damage assessment has happened. And in this case, we came across different kinds of points of interest data to attempt to assess where the damages have happened. We We use a lot of social media data as well as perform a lot of natural language processing and extraction to identify what people are talking about, what pictures have been shared before and after a disaster, and where the information can be the most important for the first responders. We use these kind of social media as well as blogs and other information to extract something that's more relevant as well as important for the disaster recovery to be happen as soon as possible. Finally, we were able to identify what buildings have damaged, the level of damage that has happened to these buildings, as well as how we can recover from these damages. The final and the most important that we found was in our backyard in 2016 when the Smokies wildfire happened. A large part of the Great Smoky Mountain National Park was burned because of some wildfires that have been human-made. And we use social media data in this case to identify and track the assessment of damages that have happened. So this is kind of just a capture of way of how social media data can also be used, and through pictures be able to identify the damages as well as the location of the damages that have happened for this disaster. This is just a rundown of how a small event can be captured towards creating a much larger and a bigger event that translated into a lot of power lines being shut down. The entire city of Gatlinburg was evacuated during that time, and over $4 billion worth of damages have happened during this time. So when we look into these ideas and try to capture some of this information, it's important for us to know that these information and these data sets come from anywhere. So we need to have a platform that is all encompassing and can be used as a way to create scenario-based mitigation efforts for disaster recovery mechanism. Also recently, the disinformation and misinformation campaigns have kicked in during these critical times. So how we can defend ourselves during this disaster and make sure that the information that is created is authentic and has to reach the right person at the right time. Thank you very much, and I'm open to take further questions.